Hello students, good morning one and all. In last class already I given the brief introduction about calculus. What is meant by calculus, what are the parts of calculus, and so in parts of a calculus, so already I given brief introduction about differential calculus. In differential calculus we have one chapter, that is continuity and differentiability. Continuity and differentiability. Before going to differentiability and differentiation, we must know continuity. Without continuity, so the differentiability will not happen. So now here continuity means, here continuity and discontinuity. Continuity means, for example, parabolic function is there. This is the parabolic function. Okay, I will give general definition and technical definition both. Okay, I will give general definition and technical definition. Now continuity means drawing the curve without lifting a pencil or pen, that is called a continuous function. Continuous function. Okay, drawing the curve without lifting a pen or pencil is called continuous. Okay, for example, your modulus function is continuous, your polynomial function is continuous, and identity function is continuous, but greatest integer function is discontinuous. Okay, for example, you traveling from Bangalore to Hyderabad. Okay, you are traveling from Bangalore to Hyderabad. So there is no break. There is no break for bus. There is no break for bus. That is called continuous. Okay, suppose so there is a break for a bus. That is called discontinuous. Okay, we can draw the graph without lifting a pen or pencil. Now I am using a chart piece. So without lifting a chart piece, okay, that is called continuous. Discontinuous. Discontinuous means, this is greatest integer function graph. Okay, this is greatest integer function graph. This is called discontinuous. Okay, so there are two types of functions. One is continuous, another one is discontinuous. Continuous means to draw the curve without lifting a pen, that is called continuous. To draw the curve with lifting a pen, so is called discontinuous. Best example for continuous, hyperbolic function or polynomial function or modulus function. So best example for discontinuous means, that is greatest integer function. So these are the basic definitions. These are the basic definitions for continuity. These are the basic definitions for continuous and discontinuous. So now come to our mathematical definition. That is, f is a real valued function and a subset of real numbers. F is real valued function. Real value, here there is two functions. Okay, so real function, real valued function. Real functions means the subset should be domain. Okay, so real valued function means the subset should be domain, range. Okay, real valued function means the subset should be range. Okay, real function means the subset should be domain. That is, f is a real valued function and a subset of the real numbers. Let C be a point in the domain of f, then f is continuous at C if limit extends to C, f of x is equal to f of C. Okay, for example, limit extends to A, f of x is equal to what? F of A. This is also continuous. Okay, that is, limit extends to 1, f of x can be written as what? F of 1. That is, limit extends to b, f of x is equal to f of b. These are all continuous function. Very simple. Continuous function means if f is a real valued continuous function and a subset of real numbers on the domain of f, then limit extends to c, f of x is equal to f of c. Such a function is called continuous function. This is the mathematical definition for continuous. Okay. Now I will give example for continuous. See children, so how we can check continuous function means, suppose f of x is equal to 2x plus 3, find limit extends to 1 f of x, that is limit extends to 1 f of x is equal to limit extends to 1 2x plus 3. That is 2 into 1 plus 3. 2 1s are 2, 2 plus 3, that is equal to 5. Okay. Limit extends to 1, f of x is equal to 2 plus 3 is equal to what? 5. Okay. That means the function is continuous. Just function is given, just you have to find the value will come now. We got some value now, that is called continuous. Only one function is given means like this. Suppose like this, they will give f of x is equal to 2x plus 5, 3x plus 2, x square plus 1. I have to check. So by using LHL, RHL. Okay. So this type of problems we will discuss laterly. Now I will give introduction about something. And again, so this type of problems are very, very important for 4 marks. Okay. Please observe here. The function is given. This is polynomial function. All polynomial functions should be continuous. You keep in the mind. All polynomial functions should be continuous. All greatest integer functions should be discontinuous. Okay. Discontinuous means the value will not come. Okay. That is called discontinuous. Continuous means we got some value. That is called continuous. Continuous and discontinuous. Continuous means to draw the curve with lifting a pen. Discontinuous means to draw the curve with lifting a pen, without lifting a pen, with lifting a pen. Okay. Best example. Okay. Now I will take one more example. Suppose f of x is equal to x square. So f of x is equal to x square. Limit extends to minus 1. Find limit extends to minus 1. That is limit extends to minus 1. F of x is equal to limit extends to minus 1 x square. That is minus 1 whole square. That is 1. That means this can be written as f of 1. We got some value. When you got some value is there now, that is called continuous. That is limit extends to c, f of x is equal to f of c. General form. Okay. We got some value, that should be a continuous. Okay. Now we will move on. Algebra of continuity. Algebra of continuity. See children, here algebra of continuity, here we can remember algebra of functions, that is f of x plus g of x, f of x minus g of x, f of x into g of x, f of x by g of x. That is here, therefore f plus g is continuous. First one, f plus g is continuous at x is equal to c. f plus g is continuous at x is equal to c. Therefore, limit x tends to c, f plus g of x of c is equal to limit x tends to c. f plus g of x can be written as f of x plus g of x. This can be written as limit x tends to c, f of x plus limit x tends to c, g of x. Separate the limits here. That is, so this can be written as f of c plus g of c. This can be written as f plus g of c. Therefore, f plus g is continuous. Therefore, f plus g is continuous at x is equal to c. Therefore, limit x tends to c, f plus g of x is equal to limit x tends to c, f of x plus g of x. Limit x tends to c, f of x plus limit x tends to c, g of x. f of x can be written as f of c, g of x can be written as g of c. This can be written as f plus g of c. Similarly, next, second one is f minus g. f minus g is continuous at x is equal to c. Therefore, limit x tends to c, f minus g of x. Therefore, limit x tends to c, f minus g of x can be written as f of x minus g of x. That is, limit x tends to c, separate the limits, f of x minus limit x tends to c, g of x. This can be written as f of c minus g of c. This can be written as f minus g of c. Therefore, f minus g of x can be written as f minus g of c. Therefore, f minus g is continuous at x is equal to c. Okay. Therefore, f minus g is continuous at x is equal to c. You have to prove limit x tends to c, f minus g of x is equal to limit x tends to c, f of x. Already we studied f minus g of x can be written as f of x minus g of x. Limit x tends to c, f of x minus limit x tends to c, g of x. f of c minus g of c. This can be written as f minus g of c. Now we will move on. Next we will move on. fg. fg is continuous at x is equal to c. Same similarly, limit x tends to c, fg of x can be written as limit x tends to c, fg of x can be written as what? f of x into g of x, and substitute the limit f of c into g of c. This can be written as fg of c, fg of c. Next one is f by g. This is third one, this is fourth one. f by g is continuous at x is equal to c. Therefore, limit x tends to c, f by g of x is equal to limit x tends to c, f of x by g of x can be written as f of x by g of x. This can be written as limit x tends to c, limit x tends to c, f of x can be written as f of c divided by g of c. f of c divided by g of c can be written as f by g of c. Therefore, fg is continuous at x is equal to c. f by g is also continuous at x is equal to c. These are the four algebra functions of continuity, and they exist in a scalar. How means that is lambda of fg is there. Lambda of fg can be written as fg of lambda. Okay, their existence of a scalar. Okay, these four properties are very important. F plus g is continuous at x is equal to c. F minus g is continuous at x is equal to c. fg is continuous at x is equal to c. f by g is continuous at x is equal to c, and also their existence by a scalar. And you remember, children, all polynomial functions are continuous. You remember, all polynomial functions, whether it is parabolic or hyperbolic, okay, whether it is parabolic or hyperbolic or elliptical functions, all polynomial functions is continuous functions. All greatest integer function also discontinuous. Okay, so I will discuss that is discontinuous function. Okay, so here continuous and discontinuous, it is very important. Don't confuse. Continuous is different, discontinuous is different. Continuous means we have to dot we will get the some value, that is continuous. Okay, discontinuous means, so it should be checking LHL equals to RHL. When LHL equals to RHL will come, that is continuous. Okay, when LHL not equal to RHL, that is discontinuous. Clear? Now I will move on. We will move on. Exercise. In this exercise, 4-mark question is very important. That is exercise 5.1. This is 5th chapter. So first problem is prove that the continuity f of x is equal to 5x minus 3 at x is equal to 0, minus 3 and 5. Very simple, just we will find the value. See children, that is limit x tends to, first value is 0, f of x is equal to limit x tends to 0, 5x minus 3. Therefore 5 into 0 minus 3, that is minus 3. f of x is, just we have to find the value, that's all. f of x is continuous at x is equal to minus 3. So here limit x tends to minus 3, f of x is equal to limit x tends to minus 3, 5x minus 3, that is 5 into minus 3, minus 3. 5 3s are minus 15, minus 3, that is minus 18. f of x is continuous at x is equal to minus 3. Now come to 5, 0, minus 3, 5. Limit x tends to 5, f of x is equal to limit x tends to 5, 5x minus 3, 5 into 5 minus 3, 5 5s are 25. 25 minus 3, that is 22. Therefore, f is continuous at x is equal to 5. Very simple. You are checking the continuity, very simple. Just substitute the limit and you will get the value that is continuous. Okay, so I am concluding the class. Okay, so this is the first problem in exercise 5.1. in remaining problems of exercise 5.1 we will discuss laterly. Okay, thank you one and all.